Hi everyone, welcome to AI Crack channel. This is Akash Gangwar and today we'll be studying circles lecture 3. So in previous lecture we talked about position of a point with respect to circle and different special conditions of circles. In this lecture we'll be talking about position of a line with respect to circle and point form of tangent and the denotation. Okay, so let's start with position of a line. So let's say we have this circle over here and this is the center h comma k over here. Okay, and now this is the radius. If I draw one particular line over here, let's say this line is L1. If I draw this line, what can I say, that this line is outside the circle or cutting the circle or tangent to the circle? So that how can you define that? So basically if I drop a perpendicular from here on this particular line, and if this and that distance comes out to be bigger than a radius, in that case this line would be outside the circle, basically not even touching, not intersecting. And if this distance comes out to be equals to radius of the circle, that means the line is tangent to the circle. And if distance is coming lesser than radius, then that means the line is intersecting. Okay, so we have three cases over here. So let's look at the first case. So this is r, so this is center h comma k, this is distance r, radius r basically, and line is outside the circle. In that case, let's draw the line over here, somewhere over here. So this distance, this perpendicular distance is d, and we already know how to find out the perpendicular distance from a point on a line with the help of that formula: ax1 plus by1 plus c divided by under root a square plus b square modulus. Right? We know this formula. If this value comes out greater than r, that means basically d is greater than r. That means this line is not touching and not even intersecting the circle. Okay, so that's our first case. For the second case, we have a similar condition. This is point h comma k, this radius is r, and this distance is d. So basically the line is touching somewhere over here. That is, this is tangent over here. So that means d equals to r. If this equation has this line has equation ax plus by plus c equals to 0, that would mean d equals to modulus of ax1 plus by1 plus c divided by under root a square plus b square equals to 0. Here x1 and y1 are actually h and k because we are dropping the perpendicular from this point. So x1 and y1 are h and k. Don't confuse them with x1 and y1 from outside point. So these x1 and y1 are actually from h and k. Okay. And the third case is the obvious one, where this line is cutting this particular circle. This is radius r, this is radius d, and d is less than r. D comes out to be less than. You might see certain formulas in the books for standard circles. You don't really have to remember them because that's an additional load, and they are applicable only to certain standard circles, not every circle. These conditions which we are talking about here are applicable everywhere because we are talking from basics. We are talking about distances equals to r, less than r, or greater than r. So that is applicable for all sorts of circles, but not only for these special circles. But the conditions or the formulas given in the standard books, they are meant only for standard circles, and you might forget that when to apply those formulas. So it's always better to stick to the basics. Now let's look at this example. The circles x square plus y square equals to 4x plus 8y plus y intersects the line 3x minus 4y equals to m at two distinct points. So we have to find out the range of m. So basically we have one circle over here. So the circle is x square plus y square minus 4x minus 8y plus minus 5 equals to 0. And this is intersecting the line 3x minus 4y equals to m. So 3x minus 4y minus m equals to 0. This is our line. Okay. So the condition is something of this sort. This radius is r, this distance is d, and d should be less than, basically modulus d should be less than r. So this should be our condition that would provide us the inequality. Now for that we should be knowing the center point, right? This h comma k over here. So center over here would be 2 comma 4 minus g minus f, right? Yeah. So center would be 2 comma 4 over here, and the line equation line is 3x minus 4y minus m equals to 0. So let's find out the d value. So d equals to modulus of, this is not modulus, d is already having the modulus. So d is modulus of 3x1, x1 over here is 2, 3 times 2 minus 4y1 minus 4 times 4 and minus m, divide by under root 3 square plus 4 square, right? So this comes out to be 6 minus 16 minus m, divided by 5 modulus that should be less than r. R over here is under root g square plus f square minus c. So g square plus f square would be 4 plus 16 and minus of minus 5, right? This becomes 20 and 25. This radius is 5 over here. Okay, so that should be less than 5. So this will open with two signs, with positive and negative sign. So that would become, this is minus, yeah. So that would become minus 10 minus m divided by 5 is less than 5 and greater than minus 5. So this becomes minus 25 minus 10 minus m and 25. So m actually minus m and this becomes minus 15. This becomes 35. So m actually becomes, because we have a negative sign over here, if I multiply negative on both sides, the inequality would change. That becomes 15 and we have minus 35. So this should be our range for this question. So we have A as the correct answer. Yes. Now let us look at this question. The equation of a circle which touches both axes and lines 3x minus 4y plus 8 equals to 0 and whose center lies in the third quadrant is. So we have this coordinate axis, and since it has explicitly mentioned third quadrant over here, and it's also touching both the axes. So we have this radius r over here, right? And this coordinate would be minus r comma minus r, because r is always positive because it's radius, it's length. So r is positive. So that is why, since this is in third quadrant, we have to consider minus r and minus r over here. And this is how our circle looks like. Okay. Now there is one line that is also touching the circle, and let's draw it like this. I'm not plotting the exact line because you don't really need to. You will see why. Okay. And we have to find out equation of circle, and this is the particular tangent. Okay. Now the equation of this line is 3x minus 4y plus 8 equals to 0. Now the obvious thought is we know this particular point and we know the equation of this line, and radius that should be equals to distance of this point from this line. Basically perpendicular distance from this point on this line would be equals to radius, right? Because that is tangent over here. So I'll write the formula as 3 times minus r minus 4 times minus r plus 8 divided by under root 3 square plus 4 square modulus. That should be r, right? So that would give me modulus of minus 3r plus 4r, that becomes r only, and r plus 8 divided by 5 equals to r. Now if you open it with two signs, you'll be getting r plus 8 divided by 5 equals to minus r, or r plus 8 divided by 5 equals to r. That becomes r plus 8 equals to minus 5r, or r plus 8 equals to 5r, right? Now this would give me r equals to 2 over here, and this would give me r equals to minus 8 by 6. And that's not possible because r is the positive number. Okay, r is the radius and that's a positive number. So that's not possible. R equals to 2 is the correct answer. Now, once we know the r value, we know the center coordinates, we know the radius, we can find out the circle, equation of circle, right? And now I'll tell you why we don't really need to worry about the placement of this particular line, because what we are doing, we are just, we know that this line is tangent, and if we draw the perpendicular from the center on this line, that would be equals to r only. So we just have to use the formula. We don't really need to worry about the placement of the exact line, and that's not going to help us anyway in the question. So question solving. Okay. Now let's talk about tangents and point form and T notation. So just like S notation, that is very important for the entire conic chapter, conic sections. So this T notation is also going to be of similar importance, just like S notation. Okay. And we'll be using this T notation in other conics as well, parabola, ellipse, hyperbola as well. So we'll start from the standard circle, and then we'll use the analogy for the general circle as well. Okay. So let's draw a general circle over here. This is having center at 0, 0, and let's say this is the tangent, and this point is over here is x1, y1. Okay. Now in the point form or t notation, basically we are deriving for the point is on actually on the circle. So basically we're not deriving for a point which is somewhere over here and then we are using this tangent point form. We're not doing for that. We are deriving for when the point is on the circle and we have to draw the tangent at that point on the circle. Okay. Now we know that if we draw the radius over here, it would be perpendicular to it, and we can find out the slope. Slope would be m over here would be m, that is normal over here. M normal would be y1 minus 0 divided by x1 minus 0. That would be y1 by x1. So m tangent would be minus times x1 by y1, right? Now if I want to write the equation of this tangent, that would be y minus y1 equals to m tangent times x minus x1, right? M tangent is minus x1 by y1 times x minus x1, right? If I expand it further, I'll be getting y minus y1 multiplied by y1 equals to minus x1 times x minus x1. So that gives me y1 minus y1 square equals to minus x1 plus x1 square. So this becomes y1 plus x1 equals to x1 square plus y1 square. This looks like this. Now this equation is basically called as T notation equation. Let's see how. So I can write this x1 square plus y1 square as r square only, because x1 square and y1 square is this coordinate only, and this is, if we talk about this as the origin, then this distance is y1 and this distance is x1. This is y1, this is x1, and if we square both of them, that would give us the radius only, right? So this is becoming r square. So 5y1 plus x1 equals to r square. If I take r square towards here, I'll be getting y1 plus x1 minus r square equals to 0. Now this is the T notation format. Okay. So in case of T notation, we actually do the transformations. In case of S notation, we actually took everything on the left side and then we applied the point over there. But in case of T notations, we first do the transformations and then we apply the point. Okay. Let's see how do we do it. So let's say we have this tangent equation. We have the circle equation as x square plus y square minus r square equals to 0. This is our circle equation, right? Now if we want to apply the T notation over here, x square goes to x1, y square goes to y1, x goes to x plus x1 by 2, and y goes to y plus y1 by 2. So these are the transformations which you have to remember when you are writing the tangent equation directly from the circle equation. So basically this is circle equation, and now we have to apply the T notation by doing these transformations, and then we'll be getting the entire equation of this tangent. Okay. Now the point over here is this x1 and y1 is lying on the circle. It's not a point which is outside the circle. We'll be talking about different points as well with the help of same T notation. But in this case, if we want to write down the tangent equation, the point should be on the circle. That x1 and y1 we are using in the transformation, that point should always be on the circle, and then only you can write this tangent equation in this T notation format. Okay. So these are the transformations which you have to remember. X square goes to x1, y square goes to y1, x goes to x plus x1 by 2, and y goes to y plus y1 by 2. And you have to remember that this point is lying on the circle. Okay. So this is how you have to write the tangent equation in point form. Now let's solve this question. The angle between the tangents to circle x square plus y square equals to 169 at the points 5, 12 and 12, minus 5. Now you can see that these points are actually lying on the circle. If you put 5 over here and 12 over here, you'll see that you'll get the summation as 169. So these points are actually lying on the circle, and then that's why we can write down the tangents using the T notation. So we have x square plus y square minus 169 equals to 0 as the equation circle. Now if you apply the transformations over here, we're getting x1 plus y1 minus 169 equals to 0. So the first point is 5, 12. So that would give me x1 5 plus x times 5, y times 12 minus 169. So basically that becomes 5x plus 12y minus 169. The second equation would become 12x minus 5y minus 169 equals to 0, right? Now we have to find out the angle between these two tangents. Now you can clearly see that over here m1 equals to, basically slope of this line equals to minus times coefficient of x divided by coefficient of y. Over here m2, basically slope of this equation is minus time coefficient of x divided by coefficient of y, that is 12 by 5. If we take the product of these two, we'll be getting minus 1. So if m1 m2 equals to minus 1, then angle should be 90 degree. So that is D is the correct answer. Okay. So this lecture was still here only, and we talked about important concepts over here. So in the previous lecture, we talked about S notation. That is also very important in terms of conics. We talked about T notation in this lecture. That is also very important in terms of conics. And you'll be remembering these notations for future references in parabola, ellipse, and hyperbola as well. So let's meet tomorrow. Thanks for watching.